Welcome. All right, so what I'd like to do is show you how to solve this quadratic by factoring using really any method that we want to look into. Now, when using various methods, it's very, very important always to kind of look and see, if we can factor something out, if we don't already see a perfect square. And, I see this 256, but I see 40, and I know that 40 is not a perfect square. So, therefore, I'm not going to be able to use the perfect square trinomial, and therefore, I'm going to want to factor out our GCF of this equation. Now, you can see I'm dealing with some pretty big numbers. And fortunately, these are all even numbers, so I know I could divide out a 2. But when we're looking into factoring out, we always want to see, can we factor out the largest number, our greatest common factor? So to do that, I go to our smallest number and say, all right, what would be the largest number that divides into 40, but then would also divide into these other two terms? And so I look at 40, and obviously 40 doesn't divide in these two. Then I look at 20. 20 doesn't divide in these two either. Going to 10, 10 doesn't divide in these. But then when I work into 8, when I calculated this, I was able to determine that I can factor out an 8. So I'm going to, since I'm solving this, I'm solving a quadratic. I'm going to set my f of x equal to 0. And when I factor out an 8, I'm left with 32. Hold on. Let me show factoring out an 8. So I'm left with a 32x squared plus 36x minus 8 would be 5. Okay? So now what's nice about factoring this out is it's not going to affect my solution, because now these two are our product to equal 0. I can just divide this, and therefore I have 0 equals 32x squared plus 36x minus 5. So now I still need to factor, and you can see my a is very, very large. And a lot of these type of factoring, this gets a lot of students. Again, we look at this, we look for any type of special factoring techniques. It's not going to happen. So therefore, now what I'd like to do is to factor this using the AC method. So to do that, I'm going to multiply my a times my c. When I do that, I get a negative 160, and then they need to add to positive 36. So therefore, I need to look at the factors of a negative 160 that are going to add to positive 36. Now, you can work through a lot of numbers that divide evenly into 160. But what I was able to come up with was positive 40 and negative 4. Because that gives me 160 when I multiply them, negative 160, and they add to a positive 36. Therefore, I'm going to take those two terms, and I'm going to write those as my interior terms. So therefore, this says 32x squared. And then instead of writing 36x, I'm now going to write a positive 40x minus 4x minus 5. Oops. We'll put that back in red. So now what you can see is now what I'm going to do is I'm going to break this up as far as into grouping. So what I wanted you to notice about this is I broke our middle term into 40x minus 4x. Now I can go ahead and factor this by grouping. So now I need to determine what is my greatest common factor, again, out of those first two terms. And what, again, we can see is that my greatest common factor is going to be 8. So I'll factor out an 8. And when I do that, I'm left with a 4x squared plus 5x. And then in this case, I want to factor, you can see that these, I can't factor anything else, but I want it to be the same as this factor. So I'm going to factor out a negative 1. And when I do that, I'm left with a positive 4x plus 5. Now you can see that these two terms are exactly the same. So I'm going to factor that term out, and I'm left with 0 equals 8 minus 1, or 8, sorry, 8x I should factor out, right? So when I factor out an 8x, I'm left with the linear term 4x plus 5. So I have 8x minus 1 times 4x plus 5. Now I can apply a zero product property by setting them both equal to 0. And just by solving this, I get x equals a positive 1/8, and x equals a 5 or negative 5 divided by 4. So there you go, ladies and gentlemen. That is how you solve a quadratic using various methods. Thanks. Bye-bye.